Alright, on question 34, 35 will be done the same way. We need to solve for both x and y. In this case, it's probably going to be easiest to solve for y first. So we have two central angles. We have a central angle here, and really the rest of this central angle makes up the full circle. So it makes up a full 360 degrees. So to find the measure of this central angle, we would just take 360 minus 90, which gives us 270. So therefore, 15y minus 30 has to equal 270. When we add 30 to both sides, we get 300 equals 15y, therefore y is equal to 20. So that's y. Now the next thing we have to do is we have to solve for x. Now x is an expression here, 13x plus 2, or the quantity 13x plus 2 times y that's used to represent the length of an arc. Okay? So the formula for arc length is the measure of the arc, or its corresponding central angle, which we know is 270, over 360 times the circumference. Because we're given radius, again, we'll use 2 pi times r. R in this case is 10. So the arc length, which they're giving us as 13x plus 2 times pi, has to equal 270 over 360 times 2 times pi times 10. So what we have is 13x plus 2 times pi equals 3/4 of 20 pi. Now the reason we're going to leave it in terms of pi is because now that we have factors of pi on both sides, they will cancel. Before I cancel them, what I'll do, and you could cancel not at any point, I'll take 3/4 of 20, which is 15, so this is going to be equal to 15 pi. Makes it a little bit easier to see. So now that's gone, and this is gone. So all we have left then is the equation 13x plus 2 is equal to 15. When we subtract 2 from both sides, we have 13x equals 13. Divide both sides by 13, so x is equal to 1. So x must be equal to 1 in order for this arc to measure 15 pi, which we know it must because it's 3/4 of the circumference of a circle with a radius of 10, which would give us a total circumference of 20 pi, and 3/4 of that is 15. So that's what it has to be in order for this to work. And that is how you solve question 34.